Hello student, welcome to the Foundation of Classical Electrodynamics course. So we are in module 2, understanding electrostatic, and today we are going to discuss about the Coulombs law. The last class also we intend to discuss, but due to the time constant we couldn't. So let us now do it in this class. So it is class number 22, where we discuss the famous Coulombs law. So I think most of the students is already aware of the Coulombs law, nothing new here. So let me go through this law once again. So suppose you have a source charge here, say Q, and at some distance r you have another charge which we call the test charge BQ. Okay. So then the force between them is simply written in this like inverse square law. So force between them is 1 by 4 pi epsilon 0 is constant, and then q divided by r square unit vector r, when unit vector r is simply r vector divided by mod of r. Okay. The value of the epsilon 0, which is called the permittivity of the free space, is roughly 8.85 into 10 to the power of minus 12, then Coulomb square per Newton meter square. And 1 by 4 pi epsilon 0, if I calculate, instead of calculating epsilon 0, it is of the order of nearly equal to say 9 into 10 to the power of 9 then Newton meter square divided by Coulomb square. So this is for single charge. What happened if there are multiple charges are there? So I need to put a coordinate system now, simply x, y and z, and instead of having one charge we have a charge distribution, but these are the discrete charges. So suppose this is my qk, and from here to here the coordinate, the distance is rk, and my test, this is my source charge, my test charge is sitting somewhere here, bq, somewhere here. So the location of this charge from this coordinate system is say r, and from here to here this is the distance between the source charge, and this I can write r k with a curly notation. So curly r k is nothing but vector r minus r k, right. So for this particular charge q k, if I want to find out what is the force, then the force due to the charge q k, so that is why I put a k here, it should be 1 by 4 pi epsilon naught, then q k q divided by r k square and then r k unit vector Carlier. Okay, now the total force, because there are not only one charges, other charges are also sitting here. So, if I want to find out what is the total force on this charge q, test charge q, so then the total force F total should be the vector sum of all the force. There is some sort of superposition. So, so I should have a vector sum where say k goes to 1 to n, because there are n number of charges. So, this is f k, vector f k, and that is equivalent to 1 by 4 pi epsilon 0. This is constant for all the cases. Then the sum over k goes to 1 to n, and also I can take this charge q outside, because q is nothing to do with this summation. So, then I have q k divided by r k square and then unit vector r k. Now, if I know the coordinate in r k for all the point charge, so this I can write q divided by 4 pi epsilon 0 and then sum over q k, k goes to 1 to n for all charges, divided by r minus r k, because now I am writing in terms of normal r k, and then it should be cube and r minus r k. Okay. So, this is the way you can represent the total charge on a point on a test charge q when the charge distributions are there. So, also from this one can understand when there are two charges, this is a coordinate system and two charges q 1 and q 2 are there. So, this is q 1 and this is q 2. So, we can have the coordinates of q 1 like r 1 vector, and coordinate here is r 2 vector. So, that these I can now write say r 1 to 2. So, r 1 to 2 is simply r 2 minus r 1. So, now if I want to find out what is the force between these two charged particle, so force on 2 due to 1 is 1 divided by 4 pi epsilon 0, then q 1 q 2 divided by mod of r 1 2, then 3 and then r 1 2. This is 1 force on 2 due to 1. Now, you can check that r 2 1 is simply r 1 minus r 2, which is minus of r 1 2. So, the magnitudes are same. The magnitude of 2 1 and 1 2 is same, it is obvious. But the question is, if I want to find out if I want to find out the force due to force on 1 due to 2, then it should be force on 1 due to 2 is this 1 divided by 4 pi epsilon 0, and same q1 q2, but now r will be r21 mod cube and unit vector r21. Okay, not unit vector, this is simply r21 because I am making cube here. R21. Since I am making cube here, so I just write the unit vector. Mind it, I just write the unit vector. So R unit vector is simply represented by R vector divided by mod of R. So one additional mod of R is here on top of the R square, then that is why it is R cube. Okay, but the thing is, here R21 and R12 has a relation. So I can write this as 1 by 4 pi epsilon 0 q1 q2 divided by R12 cube and then minus of R12 vector, because that relation we know. These two relation we know, and I just put this. So this quantity is nothing but minus of F12, which simply tells that this is the Newton's third law. This is nothing but the Newton's third law, and that we can simply check. Every action has its opposite, equal and opposite reaction. So the force 2 1 and force 1 2, they are equal and opposite. Okay. Now we were last class we were discussing about the how the electromagnetic how the this gravity and gravitational force and the electromagnetic force, how they are, I mean what is the weightage between these two, what is the ratio between these two we discuss. So let us do that quickly, try to find out the order. So we will going to compare quickly I mentioned in the last class. So comparison of electrostatic and gravitational force. So suppose I have an electron and proton sitting here. So this is my electron and this is my proton, and the separation between these two is r0. Now the question is, what should be the gravitational force and what should be, so the gravitational force between these two is simply, if I want to calculate the magnitude only, because both are having the same vectorial form. So this is ME MP divided by R0 square, right, where the charge of the electron, I should write it here somewhere, 1.6 into 10 to the power of minus 19 coulomb, and Me is the mass of the electron and MP is the mass of the proton. Okay, that we are going to use later. So what is the electrostatic force? Electrostatic force should be 1 by 4 pi epsilon 0, and then E square, because both the cases the amount of charge electron and proton is same, that is E and R 0 square. Now, I have to find out Fe divided by Fg, the ratio between the force, and this is 1 divided by 4 pi epsilon 0 E square divided by R 0 square multiplied by R 0 square divided by G and then Me MP. Okay. And then I can see that R 0 will going to cancel out, and what else, that is all. So, eventually I get this quantity, that E square divided by 4 pi epsilon 0, and then we have a G here and we have a Me here and MP here. All the values are known. If I put all the values, then so E I already mentioned. So, Me is around 9 into 10 to the power minus 31 kg. MP is around, mass of the proton is around 1.6 into 10 to the power, because it is heavier than electron, 10 to the power minus 27 kg, and G gravitational constant is around 6.67 into 10 to the power of minus 11 in the unit of say meter cube divided by kg second square, and all the values are, and E is 1.6 I already written here, 10 to the power 19. So, if I start putting all this value here in this equation, so Fe divided by Fg, if I start putting, just try to understand all the orders. So, I just remove all these terms 9, 1.66 just to get a rough idea. It should be say 10 to the power of minus 38, and then 10 to the power of 9 divided by what else we are having, because here E square is 19. So, that is why 10 to the power minus 38, and then we have epsilon 1 by 4 pi epsilon 0. Okay, 1 by 4 pi epsilon 0, that value I did not write, 1 by 4 pi epsilon 0, this is 9 into 10 to the power of 9 Newton meter square per Coulomb square. So, that 10 to the power 9 should be here, and rest of the term in the denominator, it should be 10 to the power of minus 11, then into 10 to the power of so what we have in the denominator, G is 10 to the power minus 11, and then Me into MP. So, if I just add these two, so it should be 10 to the power of say minus of 58. So, now if I calculate all these things, it should come of the order of say 10 to the power roughly say minus 40 or minus 39. So, you can see that how plus. So, you can see that how strong the electromagnetic force compared to the gravitational force. So, that you should realize that it is a very strong force compared to the gravitational force. Even though it is weaker than this strong force, nuclear strong force, but still it is very strong, because this is a long range force and is a very strong force. Okay. The next thing that we going to discuss is the electric field lines. So, let me simply write. So, field lines. So, if I have a positive charge here sitting and draw the field lines, that means if I make a positive charge, unit positive charge here, then the direction of the force if I measure. So, we will find that the field lines will like this. When we put a negative charge here, the field line will be inward. And when we have sign, I can have the field line like this. So, this is roughly the field line, I am just drawing by hand. It will going to be play an important role later on. So, this is the way the field line one can draw. Okay. So, there are a few properties of the field line, quickly let us write it down. So, first thing is these are the continuous curve. Continuous curves. These field lines are nothing but the continuous curves. Second thing is they cannot intersect each other. Cannot intersect. Why they cannot intersect? If they intersect each other, then at the same point they have two different direction for the force, which is not accepted. So, that is why they will not going to intersect each other. Then the third point is it starts from plus charge and ends at negative charges. So, these are the well known properties. I am just writing it down. That these are the continuous curves, they will not going to intersect and they start from the positive charge or ends at the negative one. Okay. So, already I mentioned that when we have the electric field, so this electric field, so okay, let me, so the force in the Coulombs law, when we discussed today, we discussed that there is a superposition and we have the total force, that is a superposition of all the lines. So, F k is a summation. So, to F total is a summation of F k. Now, if I try to understand that what happened for the electric field for two multiple points, then the same thing will appear here. So, the electric field, the same thing we do for the, there is an issue with the pen again. The electric field is a vector value. So, let me define first what do you mean by electric field, because electric field line I defined. So, So, the electric field E as a function of r is a vector valued function of position. This is a vector valued function of position. This is a vector and it is a function of position at different point. So, by definition I already defined that in the last class. So, E electric field is defined as limit q tends to 0 and then we have the force here and under the condition that this q tends to 0. So, this is by definition the electric field and I explained in the last class why I should take this limit. Okay. This r. Okay. Now, if I want to find out the field between two discrete points like the force we calculate earlier, it will be something similar. So, this is my one, this is okay. So, I am having r1 here, r2 vector here and the distance between these two is okay. Let me, this is the point where, so r1 is a charge point and this is r, the point where I try to find out the field and the charge point is here, q1 is sitting here. So, due to the q1 what should be the field here, that is the thing we calculate. The field at point P should be E that I want to calculate at some point r is simply 1 divided by 4 pi epsilon 0, then whatever the q r here divided by this distance which is r minus r1. So, I should write r minus r1 cube multiplied by r minus r1. This is field. The force is exactly the same. For force we have exactly the same this expression, and for field we are having the same one. Now, if there are many charges, so what should be the expression of the field? So, then the total field will be the summation of all the fields like before, and this is k, and k goes to 1 to n. So, that eventually gives me summation of k from 1 to n and then q k divided by 4 pi epsilon 0 and then r minus r1 rk and then mod of r minus rk cube. So, the point is, if I want to calculate the field for a charge, discrete charge sitting at different points and want to find out. So, these are the points where the charges are there, and I want to find out some distance here at P point, what should be the total field. So, in this coordinate system, this is my coordinate system. So, this point is my r. So, I need to calculate all the fields here due to each qk point and then make a vector sum of that. So, that will give me the total field at this point. So, in the next class we will do few problems with this superposition principle. This is called the superposition principle. If you know the field here for each point, then if you just add all these fields there, then you will get the resultant field. It should be a vector addition, mind it. So, you just need to make a vector addition of all the fields there exerted by these point charges located different position, and we can calculate the total field there. So, the next class we will do few problems related to that. So, with that note I would like to conclude here. Thank you very much for your attention and see you in the next class.